Hello, welcome to second lecture series of Basic Mathematics. Today is the first lecture of this series, and the lecture 1 I am going to talk on triangles, which will be in two parts. This is the first one of two. So this is mathematics for class 10th based on NCERT syllabus, and I am going to talk today discuss chapter 6. My name is Sangam Banerjee and my details are given below. So again we start our mathematics with geometry as what we did in class 9 standard. So I always like to start maths with geometry, and I believe that existence is a geometrical dance of shapes in space and time. Okay, so what I mean is that if you take anything like DNA has some geometrical spiral structure, helical structure, or you take say crystal structures. Okay, they have some geometrical. So again, I quote here from Plato, let no one ignorant of geometry enter. So to do maths, better start with geometry. Here I would like to point out that those who have not gone through my earlier lecture, because these triangles which we are going to discuss today is more or less an extension of class 9 maths. So I will recommend students to go through my these two lectures, lecture number 2 and lecture number 3. So you go to YouTube to go to this, you go to YouTube, search Sangam Banerjee and click Sangam Banerjee's desk channel. So you will get a channel and go to playlist, select class 10 maths and then select lecture 2 and lecture 3. I'm sure by now you all should be expert in doing this, but I'm still saying this because I have found many elders, they don't know this sort of thing, but I'm sure you all students will be knowing it for new generation. So for this chapter, I thought that it's better to start from summary. So once this is a summary of your given in your textbook, I've just copied it so that there are some 13 points. So maybe in today's lecture I will cover from point number 1 to 9. So I kept it here for completeness sake. Okay, and then in the next second lecture maybe I will cover 10, 11, 12 and 13 points. Next 4 points. Let us start with point number 1. It says that two figures have the same shape but not necessarily the same size. Okay, one can be small one, but the shapes are same, are called similar figure. Of course, only the size is different, but it can have the same shape. So then they are similar figures. Two polygon of the same number of sides are similar. Suppose polygon means you have many sides. Like triangle is one polygon, square is a quadrilateral is a polygon, pentagon is a polygon with 5 sides. So if their corresponding angles are equal, so in my class 9 lectures I have told you what corresponding angles means, what corresponding sides means. That's why it is better always, it's just 15-20 minutes if you go at very high speed. You can then come to this lecture and then this lecture will become very trivial. Okay, it's just an extension of class 9. Then this is a similar quadrilateral. What I mean by similar, this is a small quadrilateral, okay, and this is a bigger one. And if you say this side is 2.1 centimeter, this is 4. So it is a double. This length, this side is double. This 2.4, 4.8, 2.55, 3. So this is a double the size. Then you have similar triangles. So you see here similar. This is say angle x. It's just flipped here. Okay, this is just been flipped. This x angle, this y is this angle, z is this. So all angle we have seen last time. When you have an angle are same, then you say it's a similar triangle. Okay, and their ratios will be, suppose this angle here, see this is associated, this red and this blue, this red and blue q. So b by q and then say a by p and c by r, that ratio should be equal. So here I have written a by p, then b by q and c by r, and this is c by r. Okay, between this green and blue, this is between green and blue, so c and r. So this is a big triangle, this is a small triangle. This is the side of the big triangle, this small triangle. Side of the big triangle, the corresponding sides. Okay, this is big triangle, small triangle. So to test the similar triangle, similarity of a triangle, your two angles should be same, two corresponding angles are equal, or three sides are in the same ratios. This is the ratio, a by p, these are the corresponding sides, b by q, they will double or 1.5 times, any thing, but this should be constant. All these ratios should be same. Or you can have similar triangle, you say two sides are equal and the included angle which is in between these two sides. Okay, so these sides, this angle will be same, but the ratios of the side among those two triangles should also be same. So ratios of two pair of corresponding sides are equal and their included angle are equal. And of course this is not a similar quadrant. You can see here this is 3 centimeter, this is 3.5. So this 3 centimeter divided by 3 is 1, but 3 divided by 3.5 is not 1. It is different than 1. Okay, this is a stretched one, but it is not a similar triangle. Okay. Second point of your summary was all the congruent figures are similar, but converse is not true. Of course, if the figures are exactly same, they are similar, and but the converse is not true. If they are similar, one is small, one is big, so they are not congruent. Congruent means it has to be exactly same. Okay. Okay, the third point, the two polygons of the same number of sides are similar if their corresponding angles are equal and their corresponding sides are in the same ratios. The corresponding sides should be, then these polygons are said to be similar. Okay, now point 4, this I have written in bracket theorem 6.1 because this is in your textbook, this is theorem 6.1 and this is the point 4 of your summary. And it says that if a line is drawn parallel to one side, suppose this is the side, you draw a line parallel to this side of a triangle to intersect the other two sides. This will intersect this side. This is parallel, this line is parallel to this side, but it intersects this side and this side at point D and E, okay. Two sides in distinct point, then the other two sides are divided in the same ratio. So if they are parallel, then AD by DB is equal to AE by EC. They will be in the same ratio. So if this is from the middle, so this will also cut in the middle. So this and this will be same, and so this length AD will be equal to BD and AE will be equal to EC. So their ratio will be 1, their ratio is 1. But suppose it is cut in there here in say 1 by 4. So here also for this length also it will cut at 1 by 4th, okay, which you will see. So here it is written that is if DE is parallel to BC, then AD by BD is equal to AE by EC. Okay, so it can be same, it can be 1 by 4, then this also should be 1 by 4. So this is called the basic proportionality theorem, BPT or Thales theorem. So I will abbreviate wherever I use this kind of condition, I will write simply BPT. That is basic proportionality theorem. And this also you see, this is very similar to what we discussed in class 9. This is two similar triangles. This is a big triangle ABC and ADE. And you know that for a similar triangle, you have the bigger side ratios. AB divided by AD is equal to AC divided by AE equal to BC divided by D. So this is very similar to this. This is for a single, but there it was two triangles. So here it is instead of AB by AD, it is AD by DB. We will see this is almost same. When we are going to do exercises, we will see that this is almost same, means on this really is true when there are similar triangles. When you are dividing triangles, they will form a similar triangle. Such kind of things naturally crops up. How do you draw a parallel line? It is very easy that you take a compass and you have this triangle say, and now you have to draw a parallel line to this base AB. So you measure this distance BC and take a compass, put it at A and mark it here AD. And then again you measure this distance AC and take your compass at point B and mark, and you will get a point here. So this is almost the same similar triangle, and you will get if you extend this 2 point, if you draw a line, minimum 2 points are required to draw a line, and then you get a parallel. Then again you can take equal distance from here and draw parallel wherever you feel like. Okay, so to prove this condition, we may have to draw this altitude of this triangle. Either you draw this altitude are required to know the area of the triangle. So area of this triangle means this is half base, say AD by NE. This is altitude, this is height. That is equal to same thing, this same triangle. So it is either equal to AD, half AD by into NE, or half of AE times DM, MD or DM. So this you can express the area of a triangle in two ways. So here I have shown how to really draw the altitude of a given triangle. That is a perpendicular from one of the side to the opposite apex of the triangle. So this is the opposite apex of this side. So how do you draw? Suppose you have, here I have sent altitude of an acute triangle. So if you have an acute triangle here, you from here you want to draw an altitude from this point. Take a compass and from this point you draw an arc so that it cut this side into distinct points. And once you get these two distinct points, you know how to draw perpendicular. In class 9 we have done elaborately how to draw perpendicular or a bisector, perpendicular bisector. So now what you do is you take from here this point, draw an arc, and again from this point you take and draw an arc. Similarly you do here and then join this 2 point to this point. So you get this is the altitude of this triangle, and the base of this triangle is this is the base. Okay. So from where you are cutting it, that you should consider as a base. So this is your base, this is your height. So if you are cutting this one here, altitude, then this will be your base and this distance will be height. So similarly here also, if you want to consider this as base, and then you have to cut it here, this is perpendicular line and you will get it. Altitude for obtuse triangle, you extend this line here, and from this point, because you want to draw the altitude, the height of this triangle, altitude means the height. So from this point you cut this line, draw an arc and have 2 points, and once you have this 2 point, then you can have a perpendicular bisector here by similarly what I did here, that you take this point and draw one arc from here, same distance, this same circle, you same radius, okay, and take another one. So when you will not get this intersection point, suppose you take a distance smaller than this, this midpoint, then of course one arc you will get here. So you have to make it slightly bigger. So once you startly make it bigger, you can go up to here, okay, and this line will fall. So I reproduce this the same figure here. And this is the first method of proving. This is my BPT, that is basic proportionality theorem. So this is what I want to prove. So it's a very simple proof. Here I say that area of triangle ADE, this is ADE, triangle ADE, and area of triangle BDE, because I want to take this side. So if I know that this area, I take the ratio of this area and this area. So area of AD divided by area of BD is, suppose I take AD, this is the base. So half of AD into NE, where I have written here. And for triangle BDE, okay, you can see this is slanted here, this angle. So definitely you have to come to this point N, and then you have to, so this is your altitude of this triangle, because this is now more than 90 obtuse, which we saw earlier. You see here, this is outside the base. So here also you have this one outside the base, because this is more than 90 degrees. So this is a projection here. This will be somewhere on this, outside this BD. So area of the triangle BD is again same thing, half of base BD or DB times EN. So EN and EN are cancelled. So half and half also get cancelled. So I have AD by DB for this one. So again, area of triangle ADE. Now I take this side. So this is your AE, base times altitude, DM, times, now this area, triangle area DEC is nothing but half of EC. This is the base EC, and then this is the altitude. See, again here it is more than 120, so it will not lie in this, so it will go outside. And so you just think over it, you go back to the previous explanation which I have given. So here you get that area of AD by area of DEC, that is AD is half of AE into DM, and DEC is half of base EC times this altitude DM. Again here DM get cancelled, because it is the same. Like earlier, EN was same for both the triangle, for this triangle as well as for this triangle, okay. So here also DM get cancelled, so AE by EC. So, but we know that area of BDE, this is BDE, is equal to area of DEC. Why? Because we have studied also in class 9 that any triangle having a common base, and the one of the apex is on the parallel line, then the area of this triangle or area of this and area of this are same, which we have shown so earlier in class 9. So I am not going to repeat it earlier. So this is one of the theorem earlier we have studied. So please go through that. So here I write that triangle BDE and triangle A are on the same base DE and between the same parallel BC and DE. So this triangle BDE and DEC is same. Okay. So if these triangles are same, that is BD, area of triangle BD is equal to area of triangle DEC, then I can write, because then AD by this and AD by this two are same, so I can write AD by DB is equal to AE by C. So this is the basic proportionality theorem. Okay. That is AD by DB is equal to AE by EC. By a second method, as I had mentioned earlier, that in class 9 that you can have various way you can prove, but it has to be logical. So we prove the same thing, basic proportionality theorem, by another method, that is as I said that, okay, if you have this this line is parallel, so then I know that if this is a transversor, so this angle will be equal to this transversor crossing to this parallel line, and this angle will be this, and this angle is a common for this small triangle and the big triangle. So from angle, this triangle is similar to this triangle. So since this triangle are similar, that is triangle, the small triangle ADE is similar to big triangle. So this is by angle. So I can write then that ratios of the corresponding side, that is the big triangle AB divided by small triangle side AD, is equal to the big triangle's AC divided by the side of the small triangle, the corresponding side AE. So this is what I have written. This is valid for this, which we have proved it in class 9. So now I break the AB to AD plus DB and similarly AC to AE plus EC. So I get this 1 plus this AD, this is 1, this is 1. So this is also 1. AE will get cancelled, become 1. So this is 1 plus dB by AD and plus EC by AE. Okay, and this one is same, so you cancel on both the sides, so you get dB by AD. Now you rearrange it, take a reciprocal, you bring AD up and dB down, AE up, EC down, something, you just rearrange it, you will get this. So this is again the basic proportionality theorem. The difference you see, the very minute difference is there. Suppose we have two similar triangle, then the corresponding sides will have same ratios. That is AB, AD, these are two different triangles generally. But I have overlapped it here. But generally it is for two different triangles when they are two different similar triangles. But here you are talking in this one, this basic proportion, which is for a single triangle. That is only I am bisecting it. So I say once I bisect, if the bisector is parallel to the one side, then these two, this when you bisect, the divided line will have the similar ratio. This by this will be this AE by EC. AD by BD, AD by BD is equal to AE by EC. So this is the basic proportionality theorem. This is a very subtle thing, but of course from here you can go to this similarity also, and from similarity you can come to basic proportionality theorem. Okay, we will see maybe in the due course of the exercises, maybe we will touch upon this. So now point 5 of your summary, and that is same as theorem 6.2 of your textbook. So it says if a line divides any two sides of a triangle, say this side and this side, a line is dividing, then this line, if these ratios are same, then that is AD by DB is equal to AE by EC. Then this line is parallel to the third side. Okay, this is what it is written. So if a line divides any two sides of a triangle in the same ratio, then the line is parallel to the third side. So now let us prove this by contradiction. That is, we will consider that this D is not parallel to BC, but this ratio, this BPT, that is AD by DB is equal to AE by EC. This I assume it. And then I will, and then I claim that, okay, from this point D, I draw a line intersecting the other side at point E prime, and this is parallel. By construction I do it, and I say, okay, now this is your AD by DB is equal to AE prime by E prime C, because this is from the earlier theorem. I say, okay, once I draw parallel, then BPT will hold, so I get this. And here assuming, we have assumed what, E is not equal to E prime. Okay, we are assuming that this is also, this I got it from earlier theorem. Then I can say that, okay, this is same AD by DB, because this point is the same point. Then AE by EC is equal to AE prime by E prime C, because this I have equated it here. And then I can write here that I add here by invoking Euclid's axioms, that equal part 1 plus this 1 I have added in both the sides. So I will have here what? I will have here EC times 1 is, so the EC plus A is EC plus A is AC. So I have AC by EC, and also I will have AC by E prime C. Just do this very trivial algebra is there. So ACs are of course same, but it means EC is equal to E prime C. So that means what? If this length is same, means E is equal to E prime. So this is a contradiction, that is D is parallel to BC. First you had assumed that this is not parallel, D is not parallel to BC, but now you are getting D is parallel to BC. So by contradiction also, this is another way which we have discussed in our class 9 appendix. Okay, now we will discuss one example, that is ABCD is a trapezium, that is ABCD is a trapezium, and AB is parallel to DC, and point E and F are points on the non-parallel side AD, non-parallel side, this is non-parallel side, that is AD and BC respectively, such that EF is parallel to AB, such that this EF is parallel to, show that AE by ED is equal to BF by FC. This is something like that BPT only, but it is a trapezium, not a triangle. If it had been triangle, then you say, okay, it's like BPT, we have proved it. But now you say, okay, similar thing, is it true also for trapezium? Which has two, by definition, two of the opposite sides sides have to be parallel. So by BPT proof, so you draw one imaginary this diagonal, you cross it. So you have one triangle here. So this is ADC. This is a triangle, and you have another triangle. Say ABC is another triangle. It is intersect at this C. This is the point. So now you see this is a common. So I know from BPT this upon this is equal to AG by GC. Similarly, I know that CF by BF for if this is a parallel which has been given to you. So this ratio and this ratio, this is CG by GA. This is also same. So this is a common thing. So I can equate this and common thing I can eliminate. So this is how I am first thinking, and then let me write it down. So how do I write it? Say I write it that AE by ED is equal to AG by GC. So this is what I have written. And also for this triangle, I write that CG by GA is equal to CF by BF. So now this CG by GA, okay, here it is, you see CG by GA. Okay. GC or CG is the length, so it doesn't matter what I write, this one. So this is the reciprocal of it. So I just make a reciprocal and I rewrite the thing properly. AG by GC is equal to BF by FC. So this AG, these two are common. So AE by ED has to be BF by FC. So this is what they have asked. Now another example, these are a very trivial example, but anyway, let us do it so that, we have to do it. So in this example, in figure, this is PS by SQ is equal to PT by TR, okay. So this becomes, then this is by BPT, and then that means what? This line has to be parallel to this line. When I say this, is obviously which we have proved. And and here it is saying that angle PST, this is PST, this angle is equal to PRQ. This is PRQ, this angle. But I know if this is a parallel line and this is a transversor, then this angle and this angle has to be same. And then you are saying that this angle and this angle is same. So this angle is same as angle Q is same as angle R. So if these two angles are same, that means what is an isosceles triangle. So prove that PQR is an isosceles. So I am not going to prove this. You please write it down what I have said. Okay, this is another example. So in figure, this LM, this is the figure, LM is parallel to BC and LN is parallel to CD. So here I have written what, that is AM by AB is equal to AL by AC, that is equal to AN by AD. This I can get it by adding 1 to my BPT. The BPT was AM by MB. So if I add 1 to AM by MB, that is MB plus AM becomes AB. So you just do it. So you write the BPT, AM by MB is equal to AL by LC, and you add 1 plus that BPT, you will get this. Okay, I am doing it in short form because then I am trying to provoke you to think. So if I don't provoke you to think, then you will just keep reading and you will not understand the subject well. Now in 6.2.4, that is in figure, DE is parallel to AC and DF is parallel to AE. Okay, this has been given. Then prove that BF by FE, that is BF by FE is equal to BE by EC. Okay, this is what we have. So how do you prove it? So if this line DE is parallel to AC, this is DE is parallel to AC, then again I use BPT theorem, that is BE by EC, because this line is parallel. So BE by EC is equal to BD by DA. This is from the BPT. And if DF is parallel to AE, then BF by FE is equal to BD by AE, which I have written it here. So now these two are same. So I can say that, okay, this has to be same. So if A equal to B and B equal to C, then A equal to C, something like that. Now exercise 6.2.5. So in figure DE, this is DE. DE is parallel to OQ and DF is parallel to OR. Then show that EF, this is the EF, is parallel to Q. So again I use the BPT for this triangle, then for this triangle, then I take this as common. Okay, so that's what I have done it. That if DE is parallel to OQ, if this DE is parallel to OQ, then PD by DO is equal to PE by EQ. So here I have written PD by DO is equal to PE by EQ. And if DF is parallel to OR, that is DF is parallel to OR, again I can write that PD by DO is equal to PF by FR. So now I know that these two are A is equal to B and B is equal to C, so A equal to C. So I can write PE by EQ is equal to PF by. So if this is true, this PE by EQ is equal to PF by FR, that means this line has to be parallel to this line. Okay, so PF has to be parallel to. Okay, now exercise 6.2.6. It says in this figure, triangle PQR is given. In this triangle PQR, point A, B and C are point on OP. This is OP. So you are drawing, this is center point. So you join this OP, OQ, OR, and A, B, C are in these segments such that this AB is parallel to PQ and AC is parallel to QR, and prove that BC is parallel to QR. Okay, this we have to prove it. So it is again very similar to what we have done earlier. That is, we know that if this is parallel, then what? OB by BQ is equal to OA by AP, which I can write. Okay, and if this is this and this triangle, if I take, then OA by AP is equal to OC by CR. This is, so this implies what? I can always write OB by BQ is OC by CR because I have written equal to. So if this is equal to OB by BQ is equal to OC by CR, that means this is only true if BC is parallel to QR. Just go through, these are very simple and trivial exercises, but anyway we have to do it for your syllabus. And this is exercise 6.2.7. Using theorem 6.1, prove that line drawn through the midpoint of one side of a triangle parallel to the other side bisect the third side, which we have done this in class 9. So please go through class 9, and as I said, this 10th standard is a minor extension of class 9. Okay. So this is a similar triangle which we have proved earlier. So I can always write that this is a small triangle here, ADE, and ABC is a big triangle. So corresponding sides, that AD by AB is equal to AE by AC, and this is a half because this is twice, because it's saying the bisecting. So similarly, exercise 6.2.8. Again, you go through your book and you see, using theorem 6.2, prove that the line joining the midpoints of any two sides, midpoint of any two sides of a triangle is parallel to the third side. Okay. This is very similar. We have done very similar proof today also, and we have proved this elaborately in class 9. So I am not going to do this, and you please go through my lecture for class 9. That is lecture 2 and lecture 3. So now this is exercise 6.2.9. It says, if there is a trapezium ABCD in which AB is parallel to DC and its diagonal intersect each other at point O, show that AO by BO is equal to CO by DO. So I take this triangle, say I take this triangle first, and EO, and I construct such a way that EO is, I have told you how to construct a parallel line. So I have constructed a parallel line here, EO, which is parallel to AB, okay, and also parallel to DC. Because these are parallel, so if I know that if I can draw a line which is parallel to AB, it has to be parallel to DC, which we have seen in class 9 also. And using BPT for triangle DAB, that is this triangle, DE by EA is equal to DO by OB, DE by EA is equal to DO by OB. And for triangle DAC, and that is for triangle this DAC, I can always write that DE by EA is equal to CO by OA. I've just inversed it. You can always, this is actually the right way of writing is EA by D is equal to OA by CO. But it doesn't matter. I can always take this to left hand side and this to right hand side, and I can inverse it, and it will be equal. So by taking again here, you see this is DE by EA is a common, that is AED, common side for both the triangle. So then that means what, DO by OB is equal to CO by OA. So I write here DO by OA, CO by OA. So again I rearrange it. I will take this OA to left hand side and this OB to right hand side. So if you take any numerator from left hand side to right hand side, it goes to denominator, and denominator will go to, if you take it to the other side, it will go to numerator. Okay. So up, this one is called numerator, this one is called denominator. Exercise 6.2.3, diagonals of a quadrilateral ABCD intersect each other at point O such that AO by BO is equal to CO by DO, so that ABCD is a trapezium. It says, suppose you have a quadrilateral. For a quadrilateral, it need not be this, all this opposite side need not be parallel. But if these ratios are correct, if it is something like this, if you get, then of course this side and this side will be parallel. That is what it is, you have been told to show. So this is what I have written here, that if by construction we make EO is parallel to DC, then by BPT I can write AE by ED is equal to AO by CO, and this implies AO by CO is equal to BO by DO is given to us. So now we can say that this is AE by ED is equal to BO by DO. which I have written here. So if this is condition is true, that means this line has to be parallel to the constructed line has to be parallel to the AB. Thus, AB is parallel to DC because we have proved that this is by construction we have taken parallel to this. Now we have proved because of this condition, this line is parallel to. Is it clear? You go through it, it is very simple. Okay, now point number 6 of your summary. This is your theorem 6.2. It says if in two triangles, corresponding angles are equal. So this is one triangle, this blue shaded one, and this is a big triangle. And the corresponding angle means angle D and angle B. These are the corresponding angle of the two triangles. I have overlapped here, but this is, you can bring it out also, no problem. So, and this is angle E is equal to angle C. And we have to show if this all the corresponding angles of a triangle are same, then the corresponding sides are in the same ratios. So here what we have to prove is that AD by AB, this is AD by AB is equal to AE by AC is equal to DE by BC. Okay, I can take a reciprocal of all of them also. It doesn't matter. I can rearrange and do it. So this is your corresponding sides are in the same ratio. Okay, this is what we have to prove it. Given these are all angles, corresponding angles are same. So what I do, I know that this is now parallel, this angle and this angle, this angle and this angle are same. So this line has to be parallel. So I use BPT here, that is AD by DB is equal to AE by EC. I use BPT. This is given, all angles are given. Okay. And then again this triangle is same, this is congruent. Triangle AD is same. I just shifted it because this length and this length, this length and this length, this length and this BG length are same and angles are the same. So if all the length and angles, corresponding angles are same, then it is a congruent. So I can use again BPT, and from BPT I can come to this one, these ratios. These are for the similar triangle. So AD by AB is equal to AE by AC, AE by AC. So this I can get from BPT. I have shown you how to get it. So similarly for this triangle also I can use BPT and come to this BF by AB. BA is same as AB and this is BG by BC, and but I can say that this BG is equal to D, this one is equal to D, and BF is equal to AD. This is BF is equal to AD. So I substitute this BF equal to AD here. That is AD by AB, and BG is equal to DE, I substitute here. So now again I have these two are common. So I can always write that AD by AB is equal to AE by AC is equal to DE by BC. So this is what it tells, that the corresponding sides are in the same ratio. Okay, now point 7 of your sum. Two angles of one triangle are respectively equal to two angles of the other triangle. Then the two triangles are similar, that is angle similarity. So we know that if we know two angles of a triangle, then the third angle from the sum property of the internal angle of a triangle should be 180. So I can always find the third angle. So actually speaking, this angle similarity criteria is very similar to angle because third angle, if I know two angles, I can always find the third angle because sum of all these angles has to be 180. So I wrote here, by invoking angle sum property of a triangle, the third angle will also be equal. So this is very similar. Angle is nothing but angle. Now theorem 6.4, that is your point number 8 of your summary of chapter 6. If in two triangles, corresponding sides are in same ratios, then show that all the angles are equal. So how do you prove it? You have this condition of this similarity triangle side, and I write this here. That is AD by AB is equal to AE by AC, and that is DE by BC. So this condition is always obeyed for similar triangles. Okay, that is the side similarity criteria. And from here you can go to BPT, that is basic proportionality theorem, that is AD by DB. You can go from here, which we will see in the next exercise and next point. And once you get this, then you can say, okay, D is parallel to BC, hence all the respective corresponding angles will be same. So then this angle will be same as this because this is parallel. So from BPT you prove that D is parallel to BC. So any traverser crossing the parallel line will have the same angle, and this is a common angle. So we will see how we come from this condition to BPT in the next point. Here this theorem, this is point number 9, theorem 6.5. So it says if one angle of a triangle is equal to one angle of another triangle. Suppose this is the shaded one is one triangle, the small triangle, and this is a big triangle, and this angle is same. Okay, and the sides including this angle, these are the sides, so in the same ratio, that is AD by AB is equal to AE by AC. Then the triangles are similar, and this is the side similarity criteria. EE is parallel to BC given this condition. So as in the previous, I said that I will show you how to get from this similarity condition to the BPT. So here I take 1 minus AD by AB. I subtract. This is your similarity condition. So now I can write this as AB minus AD. AB minus AD is DB. DB by AB is equal to EC by, you just go through this, is very, you freeze it and see it. So then I take a reciprocal of this. So what you have, you got AB by DB is equal to AE by EC. Okay, AE by EC. AD by DB, but this is not your BPT. To convert to BPT, I want what? AD by DB is equal to AE by AC. So how do I get it? If I subtract this from AB, if I subtract BD, I will get here AD. So how do I do it? So how do I subtract? I subtract minus 1. So AB minus DB is nothing but AD, and similarly your AC minus EC is nothing but AE. Okay, here I have subtracted 1. So now I got AD by DB is equal to AE by EC. So by BPT, so now we got this BPT condition. So I can say that D is parallel to BC. So once D is parallel to BC, then I can say angle B is equal to angle D, because these are parallel and this is a transversal. Similarly here, this is a parallel and this is a transversal. So internal angle, the corresponding internal angle has to be same. So I start with this condition and come to a conclusion that all the corresponding angle has to be same. So this is angle. Okay, now another simple exercise. If PQ is parallel to RS, prove that triangle POQ is similar to triangle SOR. So how do we prove this? We know this given is these two are parallel, and then this is intersecting this here at point O, and we know that opposite internal angle, this opposite has to be same, okay, when it crosses. So this angle is equal to this angle, and since this is parallel, this is a transversal here, so this internal angle and this internal angle will be same. So I have put as a red spot. Again, if I draw a transversal here, this is the internal angle, this is equal to this. So if you see here, I have a corresponding angles are all same. There is one red here, red, one blue here, blue, and black. So these are all same. So from angle, triangle POQ is equal to triangle S. And very similar here, observe figure, this figure you observe and then find angle P. So now you see this is 3.8, this side, this 7.6. So this side are in the same ratio. This is 6, this 12. So this figure is all the sides, you make it double, you get this, but it is slightly flipped. So this angle C will be what? This 600 total internal angle has to be 180. So 60 plus 80. So 60 plus 40 is 100. 100 plus 80. So this angle has to be, angle C has to be 40. But this angle C is nothing but this angle. Okay. So this is between these sides 6 and 3.3. This is 12, and so this is in this. So this is the one. Okay. So angle P. So this is a corresponding angle. So this is a corresponding side. This side and this side. Okay, another exercise. In figure, this OA times OB is equal to OC times OD. Then show that angle A is equal to angle C and angle B is equal to angle D. So how do you prove it? So I can rearrange this. I can rearrange this as OA by OC is equal to OD by OB. OD by OB. I can rearrange. From here, it goes to other side, means it goes to denominator, and OC goes to the left hand side. It will also, from this numerator, it will go to denominator. I get. And what is given? Given is this is intersecting here. So this angle is also given. This is angle AOD is equal to angle COB. Okay, this angle is obvious. Even if it is not given, we know it has to be true. So this implies what? This AO by OC, this ratio, and OD by OB, and this one angle. So two side ratios are same. This is given. So from side angle size similarity criteria, I can say that these two triangles are similar. So if these two triangles are similar, then this side and this side, okay, that is AO by OC, AO by OC. So this angle, so you see black, and this side, this is a corresponding side. So this is a corresponding angle here, and this corresponding angle will be same. Similarly, OD by OB is, the ratios are same. So this is a corresponding angle, this red. So they have to be same. So you see this triangle have all the 3 points, 3 colors, and so it's all the corresponding angles. So angle A is equal to angle C and angle D is equal to by CPST, yeah, corresponding part of similar triangle. And now the final exercise I will do here, and I'll stop after this. This is a girl of height 90 centimeter, okay, is walking away from the base of a lamppost at a speed of 1.2 meters per second. It is walking at a speed of 1.2 meters per second. If the lamp is 3.6 meter above this is the height of the lamp is 3.6 meter and the bulb is here say. So above the ground, find the length of her shadow after 4 seconds. So she is walking at a speed of 1.2 meters per second times 4 seconds is 4.8 meters. So a distance here is 4.8 meter. And say this is the shadow distance, which we have to find what is the distance of this shadow. And now if I draw from this point E to this point A, then this triangle, this CDE triangle is equal to ABE. Okay, they are similar triangle. So since they are similar triangle, I can write that this big triangle, this side, the perpendicular side, this is the perpendicular side, 3.6, and this is the perpendicular, this girl is standing, 3.6 by 0.9 is equal to, say, this side, the big one, 4.8 meter plus x divided by DE, that is BE by DE. So 4.8. So now I have to find what is the x in the shadow. So I just rearrange it. So this is 4. 3.6 divided by 0.9 is 4. I would take from the denominator to numerator. So I had 4x is equal to, and then I subtract it. This become 4x minus x is 3x, and 4.8 divided by the 3 which I get here, I put it in the denominator. So 4.8 divided by 3 is 1.6. So shadow is around 1.6. Okay, I think now we will stop here and we will continue this triangle exercises from your textbook. Thank you and see you in next lecture.